and welcome. Thank you so much for coming to our talk. I'll try to speak slower because I'm from New York. So we talk like this really quickly. So I'm going to speak a little bit slower. Today, we're going to be talking about KubeAIOps, design patterns and strategies for AI-driven application management on Kubernetes. Again, I'm Rachel Leakin. I'm a container specialist SA with Tiago. We cover startups. I'm based in New York again. One more.
Hello, everyone. Nice to meet you. I do not speak Portuguese whatsoever. I will try to speak slow as well. Name's Tomor. I'm actually originally from Kosovo, but I live in London. I'm a compute specialist. That's a loaded term, but I look after all of our compute services, EC2 containers, HPC workloads, anything to do with compute. Work with financial services customers. There's quite a few of you here today. Yeah, if you have any questions about what we do, AWS, then come find us after the talk. And yeah, here you go.
All right. So let's jump straight into it because we have a packed agenda. And again, I have to speak a little bit slower than I normally do. Can you guys hear me though in the back? Yeah? Okay, higher, good. All right. So we're gonna first talk about why this is important. So we have the Kubernetes challenge. I mean, as you can see, the guy's quite upset, right? And that's probably most of us every day, right? With Kubernetes, we get some kind of frustration. So we have the developer struggles, right? Kubernetes is complex. It creates a steep learning curve. Most of us have been doing this, I'm sure, for a while, but there's a few of us who haven't, and it's really difficult to start. It becomes overwhelming, right? With configurations, YAML. When you get the error message, what does that mean? I don't know every single line of code in Kubernetes to know what this error message means. And then you're switching between talking to your developers, then you're talking to the platform team, to the infrastructure team sometimes. So it just becomes very overwhelming for developers. And this is what we're going to be talking about, how we want to use AI to solve some of that problems. Also, in terms of the operational reality, again, there's a gap between the developer intent and the operational execution of that intent. It takes a lot of process, multi-step orchestration, and deep platform expertise to bridge that gap between operation and developer. Here, I'll keep this with me. So let's talk about how we got from DevOps to AIOps to KubeAIOps, right? We have quite a few steps here. So as you probably all know, DevOps is automation, collaboration between the developer and the operations team, right? That's a nice automation part of blend of it. As we move to AIOps, we focus on AI-powered insights, so including like monitoring, alerting, managing response times. All of that is now how we want to use AI to power those insights and drive those insights for you. So that's what we considered AIOps in this talk here. And then we have KubeAI ops is where we're talking about autonomous agents, being able to understand the intent of the user and be able to manage your Kubernetes workloads. So that's what we're going to be considering KubeAI ops. Each of these, right, are an evolution that builds upon each other. So we've all been doing DevOps for a couple of years. Now some of us are starting to use AI, right, with our Kubernetes clusters. So now we want to push it a little bit more forward into using autonomous agents. And again, we want to focus on not being as reactive in the DevOps process and more proactive with using intelligent orchestration, bridging the gap between what you actually intend for your cluster versus when you code it in YAML, what happens, right? So we want to bridge that gap. So again, what is it? Let's just drill into a little bit more. We have an envision, Flamor and I have an envision of using agents to understand natural language. Our natural language is English, or at least mine is. So, but for the demo, you'll see we'll be doing it natural language in English, but of course, AI can do multiple languages. So again, focusing on understanding natural language to complete the life cycle of your Kubernetes operations. For developers, what does that mean? It means basically using, again, your native language instead of complex YAMLs, configurations, Terraform configurations, insert whatever language you use here. And then in terms of operations, again, it's focused on being proactive. A lot of us are reactive. I know I am. Tiago knows. Every day we are reacting to something's broken in our cluster. We want to be proactive in monitoring, using the natural properties of Kubernetes to be self-healing, and then again, using intelligent scaling without much manual intervention to keep our clusters going. So how does the agentic AI work in Kubernetes? And our vision here is I'm actually going to start a little bit lower on the natural interface there. I don't have a pointer. The natural interface. So when we talk about that, we talk about how to communicate, again, the infrastructure using plain language instead of technical commands, right? We don't want to be doing kubectl anymore. Like, why? Right? Let's just talk to it and say what I want to do. And this is how we start our projects, right? We have an intent and we know we want to build a cluster with across 3 regions that needs to be resilient, that needs to scale. We have that all in our mind. We want to be able to interact with Kubernetes in that way. And then we want to talk about how to, what we call goal-driven actors. So these are your agents that receive your objectives in our natural language, and then autonomously determines what's the best path to achieve that goal. So I know all of us have a way, and when Flamor and I build clusters, I might build it one way, he might build it another way. But with AI, we have thousands of opinions, right, on how to build clusters. So the AI can now look at what's the best way based off of what you said, right, and give you the most optimal performance, probably most common way of building it. Then we want to talk about control loops. Again, it doesn't stop with building it. It continues by we need to monitor the state of the cluster. We need to make sure that, like in Kubernetes, we're always comparing the desired state to the actual conditions of what's in production. So we want to continue that control loop model when we talk about agents and agentic agents in Kubernetes. And then again, being proactive. So moving from, again, reacting to something's broken in my cluster. I have an error in my cluster. What do I do? We want to focus on having AI to say, I'm going to automatically scale when I have this issue. I'm going to heal myself or heal the cluster when I see this issue. I'm going to optimize on scaling and cost and performance in real time. So this is how we envision using agentic AI in Kubernetes. And then Flamor is going to take us through how this kind of more in the technical details of what the different pieces are in architecture.
I have my own. So before we dive deep, I just want to get like a vibe check. How many of you are Kubernetes engineers or have worked with that? Okay, about 1/3. How many of you use AI or have used AI to do something? Okay, a lot more AI than Kubernetes. Interesting. So maybe I don't have to explain this. You already know. But ultimately, MCP is a protocol that we use to access other things that LLMs are not trained on. So historically, when they first came out, as you know, everybody was like, oh, this is a lot of public knowledge. I need to insert my private knowledge, whatever that means, for your business, for your database, what have you. And then we realized that doesn't scale because the only way to do that was to actually train your own model, which is very expensive. So we came to RAG, which was, getting access to some data in some form, but that was still also very static because it required a knowledge base. So then come MCP, whatever, like about March this year. And that's a standardized API way to talk to a service. So ultimately, any REST API is an MCP backend. Like literally, you can make anything that has REST, anything that has a API you can call that does something. Any piece of code is a MCP server. And then Google released A2A, agent to agent, and this gave birth to what we know as agentic AI today, which is how do different agents, different personas talk to each other. And this is very important for what we want to do with KubeAIOps, because ultimately, even in a regular day-to-day work, and think about this like the vision of your team, your platform engineering, your SRE, your developers, your QA, whatever have you, those personas would basically be potentially replaced by agents, or at least act as or on behalf of. So in that case, same as your developer would throw something over the fence to your production engineer and say, deploy this, that's agent A, talking to agent B through A to A and say, okay, I've built the application, deploy it. So that's ultimately the two kind of building blocks. So why or how would we do this? You can run AI agents on Kubernetes, same as you would any other application. Again, it's literally just some more code. Now, obviously, in this case, your deployed AI agent will have to connect to a LLM provider's API, be it Amazon Bedrock or Claude or OpenAI. Like, you have to speak to something that actually does the translation of the LLM. But the persona itself is just some Python code or whatever have you. And then you can run this. You can deploy this as if it was just any other application. So ultimately, you deploy this as a regular Kubernetes resource, as a pod, as a deployment. You give them personalities. And again, using A2A, they communicate same as any application would. So nothing new there. The GitOps integration bit depends on like how far you want to go with this journey. And we will discuss at like the different stages further in the talk, but ultimately, as I said, because you're replacing your personas, like your actual human and their responsibilities with agents, depends where in your GitOps workflow would such people be actually involved in. So if you have, for example, a human approval workflow like step, where somebody actually has to check whether this worked and test, verify, and then say, okay, go to production. Like, you might want to automate that or not. Depends on your risk appetite, depends on if you have like conformance, regulatory requirements, and so on. And then cluster-wide visibility is a way for resources to see what's going on, but ultimately it's not just one, right? It's not just one cluster. For the majority of our customers, it's actually a very large fleet of different classes. Sorry. So do you want to connect all of them? Do you want to just let this do its stuff on dev? Like, that also defines like how would you run or affect your end-to-end fleet with this. So we will look at what would a natural lifecycle be. So as Rachel said, we want natural language. We don't want to write any more YAML. We don't want to run any more kubectl commands. Like, we're done, right? We want to say deploy, we want to say scale, we want to say fix, whatever that means. So because LLMs and AI is actually able to do parsing and context a lot faster than humans can, you can actually whiz through all of these logs. You can actually figure out the exact error instead of having to go through tens of Grafana dashboards and logs from all of the different pods and try to figure out what the actual root cause analysis is. In this case, it kind of does it for us. So we want to have, as I said, something kind of in between, in my opinion, for most workloads at least. Like in your dev cluster, sure, you can have full autonomy. So you will have your AI agents that deploy your cluster, that deploy your application, that actually scale up, scale down, do the like testing, whatever that means, and actually tear down everything, right? So if you had a CI/CD step that tests your end-to-end flow from creation of your resources all the way to destroying and testing and everything else, then you could have that. In production, depends, like, again, on your risk appetite. So I would say potentially you want to manage some of the resources in a more automated fashion for, let's say if you want to like scale up, scale down, deploy a new version of application, that's all fine. But if I want to say actually release all of my services across all of my clusters and don't do any testing, I wouldn't do that, but up to you. And then that trust is key, because ultimately what we're trying to find out is how far can we push the system in it to give us the maximum value while we know it's not going to do the wrong thing. And that is key. If you've used AI, you know, although there's been so many promises about this, it still hallucinates. That's normal, because if you know how AI works, it's just a natural, like natural network tree. So it goes wherever you send it to. One single hint in the wrong direction, and there you go. Now you have a spaceship instead of a deployment. Like it, you don't necessarily want to end up with that, right? So being able to make sure that it does the right thing is key. But all of the tools that I described actually help us doing that as well, because ultimately, if you have all of these different personas, one of those personas could be verify whatever the other guy said, actually make sure that this matches reality. So this goes the full control loop and actually helps us achieve that trust. So caveats. Maturity is an interesting one because we have come a long way. Over the last 2 years that GenAI exists, like AI and ML is not new. It's been here forever. But the way we're actually able to use GenAI, use natural language to be able to access that massive amount of knowledge and figure out what we want is leaps and bounds over what we had, like, again, 2 years ago. But there is also a very long way forward because, including AGI, everything can be better, including like cost, including speed. Like if you've ever run your own LLM or if you have any inferencing done, you'll know how much it costs. Like there is ways to democratize this further so that smaller companies, individuals can actually use this, right? So we have further to go there, in my opinion. Security and compliance. So again, I work with financial services customers, and compliance in AI is not an easy thing because one of the biggest things around security and compliance in financial services is responsibility and repeatability. What that means is if you say X, whatever X is, you have to be able to reproduce and come back to that same X result. That can never be done with AI the way we have it today. Because again, just that's how neural networks work. So you cannot like depend on AI purely for, say, regulatory functions. That being said, a lot of our customers are actually using GenAI for ways to help them narrow down the places where they want to look at stuff. That screen is going down, not sure why. So this is actually more so, again, I'm going to use the same term, which has been very popular in AI. It's more of a vibe check than it's actually, you know, really doing the day-to-day calculations or whatever. So it depends on the industry and what the security and compliance requirements are. And then that human expertise, like you only get what you get from GenAI because of what we feed it. So the information that has been fed, that knowledge, is human. It doesn't think, it cannot create. That's normal. So all of the knowledge that you have today, if you had docs, if you had a wiki that actually describes your day-to-day operations, your clusters, or what have you, when you feed this in, yeah, that makes it a lot simpler to do stuff, but it will like not necessarily be able to learn and figure stuff out by itself. Like it's not made to do that. So what would this look like for you? I would say start small. It's actually very easy to test this out. What I've been talking about and I'm gonna show you, it's very simple to do. So we just flew in yesterday. I literally had this demo running in 30 minutes in my hotel lobby. So it would take you that much time to actually get this running on your clusters. It might not do everything you want, but it's a very good way to figure out, again, risk appetite versus how much do you want to go autopilot. Like, you might have a Tesla. Do you let it drive you? So depends what you want to get out of it. Guardrails. So again, if this is production, make sure there's a human verification step, especially for important ones. You can use the same guardrails, the same security concepts that we have for your actual human users, as well as other applications for AI as well. So again, as I said, agents would just be another application. Could run on an EC2, could run on an EKS, like could run on a pod. Ultimately, is just one more application. So give it the IAM permissions on what you want it to do. Do not over-permit. Nothing bad is going to happen. So again, there's this like chicken egg problem here, because if you say secure my cluster, but I gave you God permissions, it can go wrong. So just make sure that you build the guardrails properly. And then once you have something working, go from there. If you want to extend it to more namespaces, if you want to extend it to more clusters, more applications, then that's your next steps. And what the future is going to bring, I do not know. If I could tell the future, I would be a billionaire. So, with that, some best practices. Again, read only. I think that's a sane way to start. Boundaries are that security. Observability. So if you don't have it already, AI is not necessarily the reason to start, but you should have a good visibility of what's going on. And it's also the same, eating your own dog food is a term that we use in English. What that means is actually being able to use what you build yourself. So it's the same thing for observability. So if you have a good vision on what's happening in your cluster, then your AI agent can actually read from it and figure out problems as well. So that is kind of a requirement. So good logs, metrics, tracing, what have you. And then that human input, like being able to approve where it's important and being stopped there if there is anything critical happening. You can say something like, I don't know what the approval step is, but if you've never done this before, then ask me, right? Because it's hard to forecast future. It's hard to regex all of the possible cases where it might need human verification. You can't tell. It could be that yesterday a deploy and a scaling worked, but today it fails because your permissions expire, right? I actually want to know why or where do I have to be involved, instead of retrying it to eternity and then says, oh, I think I can do this differently, and then spawns up in another different cloud or another account somewhere. You want to make sure that it's within boundaries. And then you're all here, so you care about education, but ultimately that same, however you would onboard a new member of your team to learn how to do stuff, it's the same thing, right? This is just another tool in our tool belt. Hopefully will make things easier for us, maybe not. In my opinion, it's just one more layer to the cake. I talk about the cake a lot. So when Kubernetes added, to the world, another 4 layers to the infrastructure, from bare metal to what application developers see, is just a layered cake. So this is one more layer on the cake. So enough talking. It's okay. I'll test. Can you guys still hear me? Apparently I get a human microphone.
Yes, there's no AI for this just yet. So
I'm adjusting my mic. So I'm gonna show you some code. Again, nothing too fancy, but just so that we get an idea of what's happening. So I started this yesterday. I gave it a, I gave it a brief instruction to say, give me an application. Is that big enough? Okay. So I just said, give me an application in Node. it has a Express server, it has a endpoint, and I want you to use Node.js 22, give me the Docker file, build me the image, create an ECR repo, push the image. Now, again, a couple of things here which are important. So I am creating an application, but I am also equally creating resources for that application. Say the ECR repository. ECR is our container registry service, if you don't know. So ultimately, it's creating a registry by itself, and then it's pushing it. So this is your regular build to publish cycle. Like I'm ultimately building an application and publishing. So just for the time purposes, I did this at the break, and ultimately I do have a result here that says, I'm done, all good. If you've never seen this before, this is VS Code. And for VS Code, there is a plugin called Klein, which allows you to attach to any LLM, and ultimately you're talking to an agent. It's not deployed or agentic in the pure sense, purely due to time, but yeah. So I say, okay, I've already built it. Now, what I want to do is say, I have a cluster, and I have not tested this. This is live demo, so let's see. So ultimately what I'm now saying is, let's deploy this application. I already have a cluster that I have prepared for this. Mind you, it can also create a cluster. Now, again, risk appetite. Do you want that or not? Up to you. So it will create my resources. Like you can say it's creating my deployment YAML, my namespace. It's gonna create a service and an ingress, and then it will deploy them on that cluster. So we do now have the full CI/CD for deployment portion. So we already finished the CI first, now we're doing the CD. I might have an opinion on what some of these configuration items are. Like I might say, I want I'm in an air-gapped environment, again, financial services being one example, and I want you to create this, but it's only gonna be available within my VPC, within my private network. It's not publicly available. So let's see if it works. Yeah, I'll attach it after, I think. So you could then put those things down. On top of that, though, you could also, see, it's confused, which, surprise, surprise. So it will now block, because this is something that sometimes happens. It's trying to get my credentials, but when it stops, I'll tell it what to do. So ultimately, it can be taught at an agent level, to say, these are actually the best practices for my application. You can say, I want you to make sure that regardless what you deploy, always has a SSL certificate. I don't want clear text. And that is actually built into the behavior so that it makes sure to do that. What do you want? So. That's fine-ish. So if you have a eagle eye vision, you can, yeah, they're expired already. They are timed. It will be only worth for 3 seconds. So, hello? Yeah. So sometimes, especially for example, in the case of Klein, it starts a new terminal. See, it's starting a new terminal for every single thing I'm doing. It's like, no, reuse. And of course, there's ways around this. I just was lazy. So you could configure a AWS profile that automatically authenticates with your credentials, and then it just works. Yes, we know. You have one more chance of copying that. Yeah. Oh my. It doesn't stop, right? It keeps going. Yeah, you don't have credentials. Yes, stop. This is what happens when you do a live demo. Okay, third time lucky. Yeah, by this point you could have taken a picture, I think. It's not my fault. Let's say that. Continue deploying in the current terminal. Ooh. I think I'm out of time, but we will let it try and do its thing. Again, I promise this worked. And my demo, I can actually show you the other chat that I had. That would be helpful.
I think the moral of the story is you can see we still need some human intervention here.
Do not break me off. I'm an agent. So ultimately what I did yesterday is I deployed the application into the cluster. And then I said, okay, this is version 001. It all works. And then I was going to update that application that I built. And I was going to get it to say, hello from Cloud Native Days Sao Paulo. And then it said, okay, this is version 002 of your application, deploy. And of course, it goes and adjusts the application, builds it again, pushes it to the registry, does a full deploy with Kubernetes. I said, actually do a rolling deploy, but one replica at a time, not more. I want to make sure that it actually doesn't break my production service. Did that, created the new application, updated my health endpoint, tested 002 again, as you can see. Promise it worked. And then now you have gone the full cycle. So just for the moral of the story, we're out of time. Make sure that you build those guardrails in. Make sure that you try this. This is actually really fun. It takes away all of the pain for you. And if you have questions, come find us after the talk. Thank you very much.